Welcome to Manning Publications live stream. This is Mission Impossible DevSecOps with your Docker in Action authors, Stephen Kensley and Jeff Nikoloff. Aside from Docker in Action in our illustrious container escapades, I am the founder of K9 Security and help people integrate security into their delivery processes. So that's one of the big reasons I want to share DevSecOps stuff with you today. Jeff, why don't you say hello and introduce yourself?
Hi, I'm Jeff Nikoloff, author of Docker in Action. Been around in this space for a very long time, software engineer for 20 years. And just been kicking around in the container and distributed systems space. Since 2013. So most recently helped a lot of companies move to the cloud, adopt containers, best practices, and build some products around containers.
Thanks. So today we're going to talk about how to integrate security into your delivery processes. And this is pretty hard. So I want to set this up with a scenario that might sound familiar to you. And today is going to be a little bit less formal version of a talk that I've prepared, and we're gonna like freestyle a little bit here. So feel free to ask questions. And Jeff, this is Jeff's first time through this whole thing with me, so we'll see how it goes. And Jeff, I'm sure will ask a bunch of questions. And
I'm going to do everything I can to make sure. That we get off topic as quickly as possible.
Yeah. So let's set the stage real quick. Imagine you're a fraud analysis team, and it's a few weeks before Black Friday, and your product manager comes to you and says, "Hey, we'd really like to integrate data from this third party to combat this new form of householding fraud." And you're at your backlog or meeting or sprint planning kind of a thing, and you discuss this for about 5 minutes, and you say, "Yeah, we can do it, but we only have time to do this the quickest thing possible." You're like, okay. And everybody in the room kind of know what that means. It means that there's a bunch of schedule risk, and you go off and you start working, but there's all this stuff that can happen, and the product manager has already told the partner and the CEO or whoever that, yeah, we're going to have this partner integration done, and everybody's committed, and it's going to be live for Black Friday, and now it's your turn to cash that check. And good news, you're good at what you do, and you land the feature in prod before Black Friday. That's great. Everybody celebrates. And the public face is like, hey, yeah, this is good. And you should be happy about that. You hit it, you did the thing. But the question is but that there's a whole bunch of stuff underneath the covers that wasn't done as well as you really want. And now you have to carry that technical debt along. And the story isn't over, of course, because the system's in production, and maybe it'll be fine. And, but maybe you'll end up in the news for a security breach. And, it might just be a matter of time. Or you can go a different route, perhaps, which is to integrate security into your delivery processes. And so you can deliver those features under pressure with the security you and your customers want. So, I'm just trying to set the stage here for what it is that we're talking about. And of course, security doesn't end with like getting the thing out there. Of course, it's continuous operations. So, and the thing is that it's not that we lack good intentions. It's just that reality interferes. Engineers want to build great, safe products. Business wants to change faster, and customers need data security. So it's just that there's a lot of the problem is over constrained is one way to think about it. And this is getting faster and faster. Like we need to deliver changes faster and faster.
I mean, I think, on that, I think that there's a tension between focusing on the end state and, but there's a tendency to focus on the end state, right? And that's to say we are secure or not, or this feature is done or not, and as a result, it becomes either people don't know that they should think about how you get to the end state, or how you can use that path to the end state to harden things downstream. And almost always people lose sight of the fact that this is, especially security and operations, are things that are never done. And so if we think of, if we take on like highly manual processes for either delivering something or asserting a secure state, then it becomes either something that we have to remember that we do every single time, and plan for that, or it's something that is done once and then never again, and you risk all sorts of issues.
Yeah, right? That's right. And so one of the principles of DevOps is that we're going to be breaking our batch size down and delivering incrementally so that we can deliver change in small chunks and reap value in small chunks. So the premise of doing an analysis once, it gets invalidated. You're constantly invalidating it if you're constantly delivering value. So there's definitely a tension there, and that's what one of the big things that we want to help you understand some paths forward on accomplishing and building secure systems, because it's genuinely difficult. This is a practice, just like data science, like web development, like 24/7 operations. Security is like a very specialized field. So we can't just ignore it and like do it on the side and like have a chance to succeed. This is a reminder, if you're watching, we'd love to hear in the chat what you think is the hardest part of securing application deployments. We're not going to do the full Slido thing, but we've been asking this question and helping people answer this question for quite a while. We'd like to understand like what it is that you think is the hardest part of securing an application deployment, and we'll share our perspectives on what that is and like how that ties into actually delivering secure systems. Let's see. Okay, so I'll kick it off, and I'm sure Jeff is going to add on to this. In interviews, surveys, and so forth, I hear a lot that it's hard to get security right. There's a lot of things, especially when you're provisioning something like access is a good example. You often think about the positive case. I need to give somebody some access, but maybe you forget to deny some access, or like there might be like overlapping sets of things, and you like implicitly give somebody access to something that you didn't intend. And then there's a downstream thing that is difficult to validate. Like, did I maybe I thought of all the things that the right things to give access to, but like I can never be sure that I actually did that correctly, and somebody can find a hole to go through.
To add to that, I mean, it's not even it's even that description is an oversimplification, because no access control decision is a one and done. These are things that have life cycles, and so like being able to detect being able to think about and identify and somehow classify how and when your access control needs to change, and how it needs to change, it's all related. And so we really can't think of this as like a one-time deal, because just the nature of the beast is that it's going to change over time, either as your system evolves or as people come and go, or as the data changes, as the users in your system change. So it's even more complicated than is represented here, I'd say.
Yes, for sure. This is distilling stories into 4-sentence or 4-word bullet points.
Right.
Right. But the results, I think, are familiar too. Specialists who know how to analyze these things are overloaded, and either your project gets delayed because you're doing some analysis or doing some implementation, or you just defer it. And even if you get a waiver, that's not success. Like that's not security. So and this is going to keep coming, because continuous delivery, infrastructure automation technologies like Docker, they really enable you to go faster. And we've got some science now from the research presented in Accelerate that shows that this drives positive business outcomes. So this wave is just going to keep coming. So like, how do we, what's the solution? So recently, so my background is in systems engineering, academically, and so there's a great body of research in the safety and reliability engineering community, and I'm going to share some ideas from Dr. Levison, and one of the and this comes out of Engineering a Safer World, and there's a practice called STAMP, and what Dr. Levison says is that safety is a system property, and that we can't guarantee the safety of a system by only examining a single component or making that single component safe. Everything interacts together. Like we build and deploy complex systems, and so take something as simple as an S3 bucket. You in many systems you can't say that the objects in every bucket in AWS in your AWS account should always be private, because perhaps you have you serve a website out of one, and you should use CloudFront to keep it private. But the point is that there's a lot of edge cases, we might call them. There's just a lot of variation in our systems, and so we have to think about safety as a system level property as opposed to individually isolated components. Now we're going to have to design components in such a way that we can compose them and have them work together, so that they're secure. But we have to think about the system, and information security is an aspect of system safety. So there are many hazards to information security that can result in real harm to physical, business, or financial losses. And if you're interested in the intersection of systems engineering and safety, I highly recommend you check out Engineering a Safer World. It's fantastic. And it's useful because systems thinking provides a path forward. And the key idea in STAMP is that instead of focusing on preventing failures, that we shift our mindset to defining and enforcing constraints. So, I'll talk about preventing failures as sort of like the magic firewall solution, or, there's like this Swiss cheese model where as long as, our defenses are such that like, the holes don't line up in the pieces of Swiss cheese, like we're all good. And so the idea in STAMP is that we define and establish safety constraints for the system and let the control plane, the control system, enforce and converge operations to desired state quickly. So people who have been doing DevOps and infrastructure as code and like containers, this is actually a pretty familiar thing. Like for instance, an example in the container space is that, when you run a container, the Docker runtime will try to keep it running up until the number of failure attempts you configure in the retry. If it fails, it'll try to restart it. But this is at a system level. Like we want to be able to do things like a thermostat does. We wanted to be able to find security similarly, our goals for security, similar to how we treat a thermostat, in that let's keep our temperature in a certain range, 72 to 78 degrees, let's say. And like the thermostat's job is to like keep things in that range. And if it gets too cold, the heater turns on, and too hot, the air conditioning turns on. So we, in our systems, we might say things like our deployed containers should not have, like when we build a container image, they should have no critical vulnerabilities in them, as an example. And part of making them available for deployment to production is that they still have, less than a certain vulnerability score. And what we can do is then create libraries and processes and all kinds of supporting support within our systems to like enforce these constraints and keep our system safe. So let me stop there. Jeff, what are your thoughts on that?
I mean, so for me, I think that what we need is to bring this back in a concrete way to make it achievable, because we can talk about this at a very high level, and but it comes off pretty academic. I think that the thermostat example is really good. That's we understand that generally as a population that are used to thermostats, especially smart thermostats. But I mean, how do we bring this around to security? I mean, I think I can think of several ways, but
so most systems are going to have a bunch of rules in them. Like for instance, you might and the thing is these rules, these constraints, they're actually going to vary by what part of the organization you're in, what part of the delivery lifecycle you're in. So a good example might be that you should never be able to delete a production database. But in dev, at least there's some people that need to be able to delete databases. And so this highlights some of the complexity of the environment and the kind of systems we build. That there are certain things that we need to have. There are certain capabilities we need in order to be able to go fast. and develop and deliver changes quickly. And there are other things that like we need to be able to always satisfy the don't delete your production database constraint, or don't leave confidential data open.
Or don't do it unless you need to.
Right. And then
Right.
there's always an exception process.
Right. but make that a modeled exception.
That's right.
That's right. Kind of the.
That's right, and this actually brings up one of the most important things, which is that. So Stamp says, or it's got this idea that accidents happen when system constraints are not successfully enforced, and I've added this thing where they're missing, that like we just don't even we don't define them. And I think that's actually probably the most common issue I run into, is that like we're just not even thinking about this because it's all about hitting some date. And then you get into the sticky bits of like how they need to vary across the business and delivery lifecycle. So
yeah, I mean, but again, like that hitting that date is ultra end state focused, right? Mm-hmm. And I know that we have a very specific example that we're kind of talking through today, but I mean, in general, there's for the most part, if you're in the business of delivering business machinery or publishing digital artifacts, then this is something that it's not really a question you should be asking yourself on a one-off basis, is kind of the point, right? Like how do we use the lessons learned in one case to inform how we should be thinking about these things more broadly, and how we deliver everything that we deliver, whether it's a service or a published application or anything like that.
Right, exactly. So basically this comes down to, we need to define what our safety constraints are, and then like actually engineer that security, the security controls into the system. And so returning to our fraud prediction example, we might have some constraints like this, like we must preserve privacy of users' data. One of my favorites here is going to be that we only deploy artifacts in appropriately secured configurations. And that might be something that you can say at an organizational level. And that basically maps to policy, what often gets referred to as like a security policy, like a paper policy. But we need to realize that. And then an example of an application level safety constraint would be that we should only maybe predict fraud using like validated data, or like known valid data. And the interesting thing this leads to, like defining what your constraints are, it helps you set goals for security of the system. And align the team on what is it we're going to do and what is it we're going to build, like what components do we need. So I guess, Jeff, are these the kinds of constraints you were thinking about?
Yes, I mean they're a little bit specific, but I mean, oh, not particularly deviating.
Okay.
Yeah, sounds good.
Yeah, so let's see how this. Let's work towards application. So within information security, you often have a practice called threat modeling. That's basically this step one where you identify and prioritize threats to your information. And going through that ideation process is what, that basically is an input to the activity of generating constraints. And you then specify and record those constraints in your design doc. And then that helps set your path forward for implementing controls. And this all comes together to manage risk. And there's two major classes of security controls. There's preventive and detective. Preventive is going to help prevent problems from happening. And so like an example is authentication authorization schemes, like usernames and passwords allow a system to limit a user to only their own information, and that's a preventive control. And it's also smart to log what is actually accessed, so you can verify that users aren't accessing data they shouldn't have in an audit trail. And that way you can go back and look and see if something's wrong. And that's a detective. And if you actually have a search running and trigger an alert when something unusual happens, well, now you have a detective control. And a lot of effort has been spent on detective controls, and many organizations have a solid detective game. But a lot of organizations are now really emphasizing preventive controls and trying to push back security and shift it left in the delivery process, so that we can find and prevent problems from happening before they're in production and putting customer data at risk. They're generally less expensive to solve in development than production. So, okay.
Yeah, I mean, that makes sense. In a lot of cases, though, we're talking about preventative, not in the same way that user authentication and authorization is preventative, but more like earlier detection or preventing unwanted changes to our production systems.
Mm-hmm.
Right.
Right.
Okay.
So we're going. We'll kind of skip through the. We'll deal with this quickly. If you're using Docker, you probably picked it up for a reason. In that you're able to deploy smaller changes, or like you have a different deployment unit is one big thing. And because the technology landscape is changing significantly between cloud and traditional deployments. In the technology space, there's a ton more choices. There's there's more container orchestrators than there are really viable virtual machine platforms. And those container orchestrators have better APIs than the on-prem virtual machine platforms ever did. That's like one big advantage. There's many more identities. Like we have smaller applications, even if you're using, like if you've made the step to breaking down systems into services, or maybe you've gone to microservices, something like that, there's many more identities. Your applications are running as a particular user. And the whole notion of how identity and security policies has changed a lot too, in that it's shifted from network level controls to things provided by a platform and integrated with a compute layer. And so like that whole thing has changed. The technology has changed. The way we organize our teams has changed. We have more autonomy. And our delivery process is changing. We change at a much higher rate. Instead of a quarterly or annual deployment, we're doing monthly, weekly, daily, hourly changes. And so this all combines to invalidating our previous models around security controls. Like we need new ones that work for this new world. So DevSecOps is all about integrating security into the software delivery lifecycle. And we do that to enforce safety constraints. So what I'm going to show you here, this is a fairly classic depiction of a software delivery lifecycle. We've got some phases where we design and then we build here and then we deploy and then we operate. And what we're looking to get out of what I want to talk about next is essentially when we think about integrating security into this delivery lifecycle, there are certain things activities we need to perform and outputs we should expect at each of these phases. So in the design phase, we expect to plan our safety constraints and key security controls. And good design here sets the project up for success and eliminates a lot of rework and late surprises. We expect the build phase to produce software and infrastructure code that is mostly free from vulnerabilities. Like we might have a rule like, you can only publish an artifact into the artifact repository if its vulnerability score is less than a certain number. And that it meets other organizational standards. With the idea being that the artifacts should be ready for deployment, and if they've been published to the trusted repository. Like we should be able to take things out of our repository and then go and deploy them. And in the deployment phase, we should be able to deploy our actual system from the state defined by our infrastructure code, by our software application configurations. That could be a Docker container or a deployment spec or a Helm chart, something like that. And then in that deployment process and in our testing process, we should be able to verify the system is operating safely, that our constraints around the number of active vulnerabilities or that our system matches the state of our defined code of our deployment definition, that our system literally functions as expected, like it passes the tests, whether that's a web UI or an API test. And then during operations, in both non-production and production environments, we expect to be able to verify the application and infrastructure produce telemetry and that the system is observable, and that the operators have controls to actually manage the system. So we should be able to do things like understand what vulnerabilities are present, like what software vulnerabilities are present in production, as well as the test environment.
It's more than that, though, right? Because I mean, it's really easy to, especially if you're an image scanning vendor, to say, "Oh, software vulnerabilities, the CVEs. This is all about the CVEs," and it's really not. I mean, that's a component to it. Having awareness of what vulnerabilities are present in the software artifacts that you publish and deploy and are currently operating is certainly important. But the more important thing in my experience, and this is, feedback for the entire pipeline, is really understanding and having a tight definition of expectations for your software or for whatever you're moving through the pipeline at each phase. And identifying the appropriate place at each phase, the pipeline, to validate certain proposed constraints, right? Like for example, CVE, known vulnerability or not, in operations. If you have a system that is in operations, that is in operation, and it is behaving in an unexpected way, you have a potential issue. Either just a plain Jane operational issue, or potentially a specific security issue. But if you don't know what your expectations are for operations and what it's going to what that component and how it operates, and some idea for baseline statistics coming out of that thing, unless you have those modeled constraints, you are unable to even if you are measuring, you're not going to be able to identify when it's operating out of threshold. But you can take that back all the way back to the pipeline, right? Whether you're validating configuration of cloud resources, validating API contracts of service software that you're moving through the pipeline, validating that your authentication authorization system work, or even doing the meta thing, which is validating your delivery pipeline itself. Is the pipeline hardened, right? Does your pipeline provide integrity? Does your pipeline does it allow subversion of downstream controls? But unless we define those criteria and identify specifically where along this pipeline we're going to validate that those constraints are being met, you're not even going to be able to get started.
Right. And in fact, without defining the constraint, the measurement is meaningless. Like it's like, okay, it's just this raw data. We have a certain number of vulnerabilities or whatever, but until we combine that with some additional context, like I'll go back to the image scanning thing. If we have a Docker image in this artifact, we might have a rule that it's not allowed to be deployed to a development environment unless it passes a certain score. And I realize that vulnerability scores like CVSSs are not terrific, but that could be the rule. Whereas actually in production, you can't necessarily have that rule if your deployment config for your application that's running in production says I need this version. You can't just make that thing unavailable, because you have to decide very carefully if you should make that thing unavailable for new deployments, because you may need to be auto scaling and replacing instances or whatever all the time, and like you can't. One of the part of the CIA triad is availability. So we can't create an availability event just in order to satisfy a CVSS rule. That data is more to inform higher level rules, like should we make should we make the deployment. But yeah, and so what we're going to do is let's talk about a little bit about how design can, and like what does it mean to integrate security into design. And Jeff, I'm really curious for your feedback here. But like, let's go returning to our fraud application. Maybe they have our application team. Suppose their organization has architecture and integration standards, and those standards can provide leverage both in the design phase and downstream. So this organization happens to have some standard architectures and integration patterns, and these get used as like basically building blocks for application teams to design solutions to business problems. Because the security can be largely sorted out, and the remaining design steps become easier. And downstream there can be components that are built to satisfy organizational constraints, like maybe rules like confidential data should only be accessible between 1 and 5 principles. Or there's tagging and so forth baked in that like actually encodes our data classification model. So like a good way to integrate security into design is to be able to start with some architecture and integration standards, put together a solution, talk it over with your partners, with your security folks, like what are the threats to our information here? And maybe like the fraud team, they talked to the security team and they said like, hey, let's go ahead and integrate our data over an SQS queue. An Amazon queue doesn't, Amazon is it's almost immaterial to this thing, other than the fact that the queue is going to have a place to drop a security policy. And the security team pointed out in the discussion that like, hey, this design is going to be fine as long as you've got encryption at transport, you've got, and then you encrypt the data when it hits our side, and that only the partner that's providing the data can write to the queue, and that the queue retains data for unread messages for 7 days. And they're like, if you satisfy those things, like rock and roll, go ahead. And by the way, we have the platform team has an infrastructure code module that'll help you accomplish this. You should really go talk to them.
I think that is one of the big. So I mean, you did two things there, right? Like, if you already have some thought as an organization, if you already have some pre-modeled thought into how you do things like exchange data, which is particularly complicated and sensitive subject matter, then yeah, just like don't reinvent the wheel, use it, right? Especially if those designs have been realized as a set of constraints, like don't write social security numbers into logs. Just don't do it. I don't care if it's encrypted or not. Like that would be a nice constraint, right? And ultimately, those constraints are things that come out. In this case, they really go to inform consistent security design and code reviews, because without that, it's kind of hard. But the second thing that you said is like, really, it's important to have awareness of what you already have implemented. That's not security specific. Don't reinvent the wheel if you don't have to. In a lot of these cases, as soon as you hit your first bit of sensitive data and have business cases for putting in the effort to secure that data, secure the transfer of that data internally, secure the storage of that data, implement proper access control, auth-in, auth-z controls around that data, then 90% of the work is already done, right? Like use that model again and again and again. And in a lot of cases, especially like imagining in this specific scenario, this is a brand new group with brand new engineers that didn't have previous experience with those things. The hardest part can be discovering those patterns, discovering that design work, that security architecture that had been done previously, and even implementation. So like that you have, it's a little bit of a meta problem there, and then making sure that you can understand it after the fact is always really hard, especially if you work in a large organization where sometimes you have competing implementations, and if you're in a really big old company, then you have a whole bunch of risk around. Well, there's we have decided on the homogeneous solution for this 6 times now, and now we have 6 homogeneous solutions to do the same thing.
Sure.
So for me, when it comes to the pipeline, the design phase, almost all of the hardest problems are in those meta problems, and around discovery, figuring out really what's there, and making sure that you're not just implementing something brand new for the sake of doing it.
Right. And within a process a design process that includes a design review, you would hope that someone would raise the question or comment that, hey, this partner has been known to send us invalid data. And so the application should do some data validation, like it must do data validation on this new data, and drop it out of the model or keep it from polluting the model. But you still need to be able to do predictions with the subset, and like you need to be able to integrate a signal into your control plane and your operations to be able to like detect this detect data corruption or corrupted data as it comes in, and then like keep it out, respond to it, and so forth. And that's the kind of thing that can get very messy if you discover that you've got bad data on Cyber Monday, right? So
yeah,
anyway.
I mean that's yes, that's definitely, it's a security thing, especially in this particular example, but that's also part of any kind of, you know, ETL, extract transform load kind of work, right? I mean, it doesn't matter if it's potentially malicious data or if it's just otherwise corrupt or
Right.
does not fit the required shapes or is empty. Like that's always got to be something that we have to consider. And so especially when it comes to design, I think that the security is actually very, very, very closely related to just other pieces of, does this software do what it's supposed to do?
Right.
Especially at the application level where we're talking about like actually examining the data we're processing. I mean, that's very much so, you know, input validation. It should be part of a, does this software actually work?
Yeah.
Right.
Yeah. Yeah. I mean, that's true. And a couple pointed, a few pointed questions go in a design doc go a long way. And they point to where you need to integrate those safety constraints and security controls into your overall delivery process and like how you're going to implement them. So let's look at this proposed architecture real quick, and then like we'll jump into kind of the build and like container image building and operational workflows. So one of the big things that we got out of the design phase was that we were able to pick up a reference architecture for integrating a data source with an encrypted queue. And the key points here are that like there's lots of places to drop security policies, and so it's straightforward to implement rules and constraints that we had established previously, like that only the partner may publish to its inbox. We can do that with the security policy here. We can implement rules like only the fraud application data, only the fraud application data integration processes can update its own models. And we know that we need a plan for things like producing metrics around like what the quality of the data is coming in, so that we can enable that feature control to toggle that partner's data integration on and off. And so some of this stuff can be expensive to retrofit. If you get too far along in the process and you're like, oh gosh, now we need to like we totally forgot about authentication or like validating the integrity of our data. Let's see. So, and in terms, Jeff, you mentioned it, like one of the big things, like you need to be able to socialize what these solutions are. And so, one of the patterns that we is very common in is to create basically internal infrastructure service catalogs, or component catalogs. You have to have some sort of discovery mechanism. It can be a wiki, it could be something on SharePoint, perhaps. But that's only part of it. Like you're gonna probably want to have some sort of guild or practitioner-led forum that is socializing these things and maybe owns the development of these components.
Yeah,
Um,
you can't just in no world where these things are just passively published are they effectively used. Um,
right,
for a whole world of reasons. And so
right,
this is an active process. I mean, any kind of uh, delivering any kind of value is an active process that needs active review. And so like this is no different. Um, so like we do code review for all sorts of reasons. We do ops review for all sorts of reasons when we have things, services or software or anything in operation. We review how it's going, and so this is one of those things that either that it needs to get built into your, I hesitate to say policy, but your culture for delivery, um, and it's something that needs to be reinforced several levels in your engineering hierarchy. um, People need to look for it. They need to expect to see it, and they need to not expect, not trust that this kind of review was done. um,
right.
and where it hasn't been, push for it to be done. um, right, because that's ultimately that's the way. You have to have some active forcing function to synchronize the tribal knowledge that we have in our head with our more institutional knowledge that's sitting at rest in a wiki somewhere.
Right. And you mentioned uh, a couple practices that have worked well for me and in my experience leading migrations, so forth. One, we can talk about these in the design phase, and like that's great as a consultation. We can socialize them just like through general marketing within and education and training within a technology organization. We can have it part of checklists in code reviews and so forth, and help embed it in that the development phase. And then you can go so far as to like audit what is getting used because you're defining infrastructure and deployments as code. You can go and define that, audit that either in a source repository, or if you're tagging consistently or have some sort of tagging standard, you should be able to detect that from your deployments as well. So
Yeah, I mean, if we're talking about opening it up all the way into which I think is maybe lends itself a little bit better to some of the further stages beyond design. But you can always just say, yeah, every single one of our pull requests has to have a reference to a security review or something like that. Has to have a link. And where it
right.
doesn't, at the very least, even if there's no specific machinery that will prevent merging changes to your machinery, without it, at the very least, you have an audit trail and some kind of way to follow changes back and attribute misconfigurations or mismanagement or not following the culture that you have around change control.
Right. And I see there's a question around QA, and the question is QA traditionally hasn't been a part of security. But what are your thoughts on better engaging, leveraging existing QA teams to better test negative and security use cases? And I think QA is terrifically positioned.
I mean, it's the same thing.
Yeah, that's right.
Just because they haven't been traditionally used for it, but really, at the end of the day, every part of your delivery pipeline, especially for service publishers or for service operators, the whole thing, like it's all about making sure that the thing behaves the way you need it to, right? Traditionally, the tradition for QA is that, this behaves like functionally behaves the way we want it to, right? Like there's QA orgs out there will be writing BDD tests and they'll work very closely with product orgs to define what those things are. Sometimes only for the positive workflows, but also sometimes to discover like the negative assertions, specific things that are being blocked, etc. But I mean, if you look at software and the CVEs that are out there, like 90, some grotesque fake number, some grotesque fake percentage of them, they're all just gaps in implementation. Very rarely are we turning up security issues that are not a problem with misimplemented functionality. And so the two things are extremely closely related.
Yeah. And I would say that those negative test cases are essentially gold from a security perspective. Like, you just like in that functional test suite as part of your initial test to decide, even your initial functional test to decide whether you should even continue on deploying into a full deployment in dev. Like, you probably want to be doing some negative testing around things like authorization. Yeah. So.
Okay. all those sweet buffer overflow attacks out there, that's all just really a gap in your functional test suites. So yes.
Yeah. And so, and just to wrap this part up, your infrastructure service catalog should be filled with components that have been tailored towards your organization's requirements and like the way you do object storage, the way you do queues, and so forth. Like, these are products, internal products that are built for and consumed by internal teams. And so they, you should be able to see features on them like encryption in flight and at rest. Like, boom, I got my checkbox, right? And encapsulate the complexity there. Okay, so we'll spend let's talk about the build phase and what we can do there. So in the build phase, we're trying to ensure that software and infrastructure code is like mostly free from vulnerabilities, or like to the best of our ability, and that it aligns to security standards and is ready to be deployed to an integrated test environment. So those negative test cases should pass. At least the ones that would trigger something like a SEV1 operational incident. And application vulnerabilities are exploited in like 70% of breaches. So to address that problem, organizations are trying to secure, they've been trying to secure their software and now infrastructure supply chains. So especially with the widespread adoption of open source libraries and certain ecosystems, you have very deep and very complicated dependency chains, and so it's important to keep it's important to choose a set of software dependencies that you can afford to keep up to date.
Well, and to be a little bit more opinionated here, like it is very important to understand your dependencies, but it's also really important to understand your ability to actually be prudent in managing your software supply chain, because in some ecosystems it's a lot easier than others, and if you do come down, if you're like very security minded, like extremely security minded, it is very easy to create an environment where it's almost impossible to deliver anything, or to create an environment where your security practices provide so much back pressure that it specifically becomes a product risk, and you wind up being becoming stale.
So
I've seen a lot of bad practices in my day.
Do you think that stemmed. What part do you think a lack of clear definition about like what the success criteria for that particular rule or constraint was?
I think we there's a tendency in this space, especially around software supply chain and security scanning in that space. There's a tendency to overfit or to focus on micro issues to get way too close.
Mm-hmm.
I've worked with organizations where they actually work with third-party vendors. They spend a lot of money to maintain massive catalogs of vulnerabilities or potential issues for massive amounts of open source projects, and but then are not they end up maintaining deny lists for adoption or mandatory upgrade lists for issues that are not actually applicable, because like the Java SDK, like the Java standard library, is a big thing, and just because the Java standard library, for example, it's just a random example, has a given vulnerability in some segment of that library, we don't use it, for example, right? Like we're talking about, as fine-grained as people tend to get on looking at individual versions of individual packages out there. There's not a lot of wiggle room, or they create a whole lot of work for people to get exceptions because they're not using that piece, that impacted component.
Right.
Or just,
yeah.
Like that's a very specific example, right? But it really comes down to kind of losing sight of the forest through the trees. We're here to deliver things, and I think having a good idea of how many vulnerabilities there are in any specific code base, as the sum of its total library dependencies, is important. It's a good piece of data, but to use it directly creates a lot of risk for delivery, and it introduces a whole lot of problems that are actually really difficult to account for. That drain on your engineering core, and it really kind of, I don't know, it makes it difficult to know whether or not it was a good use of your time, and more specifically your money, or if you would have gotten more value out of just going out, taking a portion of that lost productivity budget, and buying an insurance policy,
mm-hmm.
which is probably more likely to actually protect you in the long term. I also really don't like overfitting on this, because the vast majority of the errors of the issues that I've seen out there, I mean, because at the end of the day, you're writing software, and you're way more likely to introduce your own vulnerabilities at much higher levels than you are
Right.
to be attacked by some deeply embedded thing, unless that is a very broad statement. That's not always the case. The event stream hack in NPM was a really good example, where counterexample, I'd say, where someone, basically a malicious maintainer, took control of the repository and published a minor revision to an extremely popular open source library, and they included a Bitcoin mining software in it. And so, it's a very specific type of attack that is a very, like, it's a...
Oh, hey, Jeff, you muted yourself.
Oops. But I think that, relatively speaking, those are, the risk is few and far between.
Yeah, and I think what we're talking about here actually highlights the importance of this feedback loop, like the information about vulnerabilities or whatever in your software stack. It should be available to both application teams and platform type folks, so that it can be addressed in the right place. And maybe you're at a platform org, you're going to be building a new version without the dependency that other people can depend on. Or at an application level, you can say, like, you know what, we don't use the SOAP API, so we don't in our Java application. So we're just gonna like exclude that, or make some local decision as like DevOps, devs, and modern delivery mechanisms or methods like encourage to like do the right thing. But the point, overall, what we're trying to do is produce artifacts that are reasonably free from defects so that we can deploy them. And let's skip through some of the infrastructure module stuff here, because I want to dig into scanning from a Docker perspective. I realized we just spent a bunch of time, but like, let's say our fraud detector is written in Python and deployed to Fargate, AWS Fargate using Terraform. We might use an open source tool like focusing on the infrastructure side. We might use a tool like TFSec to analyze our Terraform, and some commercial tool to like Sneak or Aqua to analyze our images for vulnerabilities. And the workflow that generally looks like is, when you're building your application image, you do that clean checkup from source, you retrieve dependencies, you build the image with essentially Docker build, whatever, and then scan it. And what you're the information that you're trying to get at this point is really just an inventory of like what's inside that image, and then it's going to you can choose at that point whether or not it should be published, like whether it's safe for publishing to the artifact repository according to your rules. And some of those rules are going to be defined at the organizational level, probably. Some of them are going to be defined at the application level, so that you can say, we don't care about that SOAP vulnerability, like let it through. And then it will be deployed into your artifact repository that is going to be the system of record for your images. And then when you go to deploy it, the deployment system will grab the image from that source and put it someplace that is useful for runtime container orchestration. And those are often on different networks, or certainly they're usually in different security zones. You have dev, you have stage and production kind of deployments. So those are often again, this depends on the exact world you live in, but those are usually segmented into different security and management and fault boundaries. So the point here is that we're gonna have a source artifact repository and Docker registry where your image is stored, and then at deployment we'll probably make a copy of that and push that into another registry that the container orchestrators can pull from.
Some kind of last mile.
Mm-hmm.
Yeah. Whether and that's the case for like no matter what you're delivering, right? Like you're gonna have last mile artifacts or last mile repositories for artifacts, just like you're gonna have last mile repositories for secrets and state and all that kind of stuff.
And we cover in Docker in Action like how image pipelines work, And one gap or one part we only spend a little bit of time on is like this whole scanning thing. There are other things you can do in your image pipelines though to verify that the image is structured as you expect, and that that Java or Python interpreter is the right version, it's executable, all that stuff, and that you can verify that your application should run inside that container as you expect.
It's like it's a massive space. I mean, you should be, checking that you're not shipping keys inside images, for example, or passwords. You can kind of go crazy with this, and this doesn't even really like talk about the challenges of securing the delivery pipeline itself.
Right.
This is all about making sure that you're valid, like doing security validation of the components that are moving through. But ultimately, if you haven't hardened the delivery pipeline, then you can subvert the entire thing anyway. That's really the back door of 2020.
Right. The easiest way to get root in most organizations is through the CI/CD system, and by root I mean admin access to the entire universe.
Yeah, this is
the entire organizational universe. But yeah, so we're trying to collect a bunch of data here, and then let's just kind of tie this back to when we're actually monitoring. So actually, I skipped too far. So once we actually deploy things, we're going to use our infrastructure code and our infrastructure in our artifacts like Docker images, which are, you might think of that, you might think of, you can think of Docker images and container images as a form of system configuration management. It's the nearly immutable variety. I don't want to troll Jeff too much on immutable artifacts. Disposable, yes, good, thank you. So Docker images and AMIs, virtual machine images, we can now think of those as disposable artifacts, and when we need to, instead of changing them to instead of running an update process to remove a vulnerability, we build a new image and we deploy that and replace containers. So it's very important that our system configuration management systems, whether that's orchestrated by a container orchestrator running containers, or Puppet, Chef, etc., configuring a virtual machine, we have some desired state, either defined by our image or by some system configuration management code, and then we have like infrastructure code that defines desired state, and like we have a process that will converge to the desired state. And then we can do other things like verify that our configurations as are we expect. So we can check for drift in our system configurations through a number of tools. We can verify that things are actually like have a secondary verification, so something like Chef inspec that actually goes and verifies that the system is configured in the way, that things like SSH with password is not allowed. Like you have to use keyed SSH access. And this is where you can run those functional tests against your application to test your authorization, to test your data integrity controls, stuff like that. So, and then drilling more specifically into like container monitoring, container deployment monitoring. The way these systems generally work is you have a monitoring application that kind of it sits and is connected to your different deployment, your different container orchestrators, and there's a monitoring agent deployed on each of those container orchestrator worker nodes. So a container worker node. So you have a Kubernetes cluster. Each of the workers would have a monitoring agent. Something like the agent from Aqua or Sneak or one of those kinds of tools, and it runs alongside your services that are deployed, and it's doing a few things. It's looking at what containers are running, what images they're using, and like tying that back to things it knows about from your registry or things it knows about from the public internet. And it's, most of those systems are going to look and see, they have large databases of vulnerabilities, and what they're trying to do is give you visibility into what vulnerabilities are actually deployed, because we talked about scanning and checking things before they hit the registry, or even once they're in the registry. But that doesn't mean what's in the registry is not necessarily what's deployed. Like very little, a very small portion of is actually deployed at any given time. And so what the main goals of these container vulnerability monitoring systems is to give you visibility into how many containers you have out there that are subject to a particular vulnerability. And so say some vulnerability starts, like it's in the news for some reason. As a team, you can, your security team, your platform team, your application team, whomever, can go and check and see, what containers do we have out there are subject to that vulnerability, and we can analyze that in the larger context of our threat model to see this thing is running SOAP. It's using the SOAP library. That thing's getting exploited right now, and that thing is publicly accessible. Like, we should do something about that, like today, versus it's an internal service, so maybe we can wait till next week.
There's a difference between there's what do we have in our registry versus what do we have deployed, and then what is deployed and being actively attacked. Right.
Yeah.
Which obviously the active attack is a little bit more pressing.
Right. And if you know, like some tools like have some notion and will try to give you some insight into if something is being actively attacked and quarantine it and stuff like that. So we'll go into that right now. Another thing that they can do is they can tell you about the security of your container configurations, like the way the container is actually configured, give you visibility into what privileged containers are out there, or what's running as root, or with the root user and so forth. So there's a few things you want to keep in mind, and you can improve the security of your container deployment straight away, usually quite easily. First, by running as an unprivileged user, you can, that's this -- user line on the example command here. You can turn on the no new privileges flag, which means that the container won't be able to escalate and add privileges once it's running. You should limit the CPU and memory resources used by the container to help contain or manage denial of service attacks. That's also really important for information for orchestrators, so they know what worker to place containers on.
The big problem here, pardon my interruption, but the big problem here and the biggest lift for people is, and this is a problem with containerization in general, is we're asking people a lot of hard questions that they generally, there are very few people within any organization that can answer. If you ask most engineers, hey, how much memory does your thing need? Does this process need? The answer will be either all the memory in the world, or as much as we can give it, or I have run it with this much memory. If you ask them how much CPU it needs, the answer is the question is unanswerable. Almost always, they'll say a CPU. Like I need a processor would be good. And that's not a criticism. It's a very specific UX problem that I've been complaining about, especially with Kubernetes since the beginning. It's one massive problem that I have with auto scaling strategies that depend on, CPU usage and that kind of stuff. It's not something that anybody understands, and for that reason, it's almost completely useless. It creates a massive point of ambiguity, and just like we were talking about with the image scanners, right? If I can bring it back for a moment, like. If you're working for an organization that uses image scanning or dependency scanning, I guarantee you they've got 2. They might even have 3. And so when those things ultimately disagree, which they will 100% of the time, which one do you trust? Right? I mean, I think one of the biggest things that we have to really push back on our tendency to want to be as secure as possible is I really want to push back on the idea that all more data is better, because it's not. If you give me a data source that is inactionable, you're specifically creating problems where, in my opinion, none otherwise existed. I would rather not scan any images and not have any information than have information that I can't actually action, or have information that just creates ambiguity. And so again, like pushing back on to adding a meta constraint here, like don't add information into your system that can't actually help you achieve your mission. Like they can't actually help you form a specific constraint. Does that make sense? I feel like I'm a little bit ranting, but this is like definitely a sore spot, right? Like if we say, oh, our things should be secure, our containers should be secure, like what the hell does that mean? Like the number of images out there that can actually run on a read-only file system is probably preposterously low. Especially images that are running for in-house software has got to be incredibly low. And so like I can say that all day long, but in reality, is it digestible? Can it be used?
So I mean, with anything, it depends, right? So let me go back to the resource limits thing. And what do you think about? So I generally agree that like a lot of the vast majority of folks developing applications, they're going to have trouble telling you what the memory and CPU usage of a given instance of their application is in production, unless they're also responsible for actually looking at that like at least once a month. Like they have some sort of on-call responsibility, and if they have if their team is doing ops, and if ops are integrated into their team's regular workflow, then they may have a good idea, or at least there's a dashboard somewhere that should probably be able to tell you tell an individual like what the say median and 1 minute maxes of say memory usage are for their applications over the past week. And like like I don't care necessarily about, from my perspective. Well, I guess, what do you think about using that data then to go and set those limits?
That's what they do,
Mm-hmm.
right? Or they just pick something that's arbitrarily high, or they set it.
Mm-hmm.
They say, well, I don't know. I like powers of 2, 16 gigabytes sounds great. And I tried it with that and it ran, so I'm happy.
Mm-hmm.
But that's not, it's but like we're talking about processing that's it's inherently fungible, right? I mean, just because I gave it 16 gigabytes of memory and I could process some transactions with it does not mean that it needed that much.
Mm-hmm.
Especially with modern, extremely dynamic, virtual machine based processes, like or garbage collected based things. Like this is not a. Most things will continue to run even in incredibly tight memory constraints or CPU constraints, because the scheduler in the operating system will continue making things run.
Mm-hmm.
So it's very like, I mean, it's still like it happens that way exactly as you described, right? But it's
Mm-hmm.
not a good answer, and it's I mean, and it, like at best, it's extremely wasteful because everybody will take something that they think is safe and then triple it to the closest power of 2, and then now we'll just encode these as memory reservations inside Kubernetes and
Yeah.
run at 8% usage, or we'll configure it. I mean, the amount of complaining I could do about the UX in this space is near infinite. I could talk
Yeah.
about like, I'm going to run my Java process and this is great. I gave my pod this much memory, but I didn't set my max heap size on my virtual machine because, well, I have to do this twice now. It's a mess. And the CPU one is specifically messy because no one understands it. Certainly no one understands the demand. So I mean that because the how much CPU does this use? Well, I can tell you that the CPU on this box is used. That's about all I can tell you. Even if they're in an operational state, right? Especially if they're moving from some kind of virtual machine land like that. And no two platforms where they could be possibly looking at this value will they come out with a consistent unit or have any idea how to translate that into the Kubernetes specific CPU units of allocation.
So I do agree that
it's
setting quota in cube reservations for CPU is particularly challenging. On the other hand, like, you will need, like, if you're building auto scaling systems, you need at least the memory reservation sorted, and then like you got to figure out how you're gonna auto scale. I agree, CPU is generally a poor metric, but well,
yeah,
I think
it's a big mess. I think the thing that I wanted to point out is, like, when we were talking about like container configuration space, like the wonderful revolution that happened with Docker, that happened with Docker in 2013, 2014, 2015, was having such wonderfully explicit callouts in a relatively simple user experience. Being able to like put that illustration up that you have right there, that one nice little command line that aggregated these concerns in such a nice way, actually helped teach a lot of people that these things existed. and brought shown a light on an entire segment of possibility out there, because we could do this for a while. It was a gigantic mess. But I still would say that the UX around even these primitives is ultimately it's too rough for most engineers to be able to reason about. Mostly not because of this, it's mostly because most engineers don't understand the more implicit contracts their software has with the systems that they run on. It's the same reason why SE Linux sucks. Because well, in order to use SE Linux, you literally have to label every resource in your entire system, and no one is going to or will ever do that. And so forget about it. If you don't have that, it the whole thing falls apart. Anyway, there's a lot of challenges just introduced with this is everything in security. A lot of challenges associated with user experience, because we are talking about an entire engineering discipline that is focused on the nuance and the gaps. We're focused on those ways that the system breaks. It's much more nuanced field.
Right. And I think the last 10 minutes have probably proven that when some container monitoring system shows in their UI, like, oh, just apply these 5 configurations, or like, you need to set your user, you need to set your CPU or whatever, like that will, it could take anywhere from 2 hours to 2 weeks to get those values correct. And where you end up depends a lot on your technology stack, and particularly your skill set, and how much data you already have around say resource usage or something like that. So this is actually one of the reasons I'm not a fan of those quick fix things in not just throughout the once a monitoring system or once a security tool starts to integrate into your control plane, or do things that are not integrated with your control plane, they're making an out of band change, and it's just going to get overwritten the next time something gets deployed or whatever. And so that's why I use words like integrate security into your delivery process, so that you're deploying your configuration from your code, which defines desired state. So
yeah, I mean it's integrate security into your delivery process, absolutely 100%. But even more important, secure your delivery process. Because that's the root of security for your entire if that is not secured, then then everything else, all bets are off. So start by adding 2FA to your GitHub accounts or something.
Right? That's an important anything that feeds this process. And so we'll just quickly touch on some operational things, which actually we've already spoken about a bit. In the operations phase, we're looking to make sure that our safety constraints that we identified up front, that they're being upheld. So things like, do we have do we only have the expected folks able to access confidential data, and integrating telemetry like we were just talking about, from what's deployed, does it match, Are there vulnerabilities out there that we should be taking a look at, and feeding all that back through our people in a judicious way. Like, this is where like the signal to noise ratio becomes really important, and giving people the ability to quickly act upon that information, because otherwise they're just gonna filter it off to some mail folder that never get looks at. Yeah. So let's see. All right. So just to kind of wrap up here, I want to leave you with a message that you can secure deployments at high rates of change, but you've got to integrate your safety constraints into your delivery process. You've got to figure out what they are and then actually integrate them so you can deliver them at speed, because every deployment is going to overwrite them. And as Jeff has pointed out several times, I want to remind you, you need to secure your delivery process. And like, seriously, it's, in my experience, the CI/CD system has been the biggest risk ultimately, but both from accidental and or malicious changes. Just think about like what it would take in your organization to accidentally delete a production database. Could you do it? From your CI/CD system?
Because from a more pragmatic perspective, like I think it's also important to say, like, security is not binary. There's no such thing as a secure or insecure thing. It's all about making iterative improvements, starting with things that you can. I love starting with, just high integrity audit, right? Like, if you are a shop that uses Git, for example, like moving to automated delivery with some kind of like GitOps flow where all changes end up in your version control system anyway, like that doesn't necessarily feel like a security feature, but it is, right? Like having that strong accountability for, not accountability as in people, but accounting for changes is massive. If you can develop a strong sense of confidence that whatever is in production or whatever is in your dev environments was at least at one point highly reflected in your version control system, then like you've got you're already halfway there, I would say. Like it's such a massive benefit. Right. And it's the requirements that you need in order to put a system like that in place are fairly low impact to the rest of the people using your delivery platform. Making sure that you're version controlling your delivery system itself, making sure that the components in your delivery system are themselves authenticated and authorized when they deliver, right? So having actual like deployment secrets, or having secrets that you use to have your automation platform publish into your artifact store. These are really important, and mostly transparent to the users of your delivery platform, right? So you can get probably 80% of the value for pipeline hardening before you even get into those more engineering or product facing changes that impact, like image scanning or specific vulnerability detection, or even before you get into contract validation in a kind of like enhanced security testing. Like that's some down the road stuff, because ultimately if you haven't secured your pipeline, if you don't have strong attribution up front, then all that stuff is relatively easy to subvert, and so it actually provides almost no value whatsoever. Right?
Yeah, and to make it clear, the demos I've seen of like, like we're gonna ship an image, like we're gonna publish an image like from Docker desktop or something like to production. That's a no-go from like what? You did what? Um, it shouldn't even be possible. And the way Jeff just described of, like running all that through delivery pipelines that are access controlled, that are pulling from trusted source systems, building on trusted build environments, and so forth. Like that's all super critical, a super critical foundation. And I'm glad you have hammered on this, because I tend to forget about it. Like I've been doing it that way. So sometimes I forget about that kind of thing. But yeah, that's definitely foundational, and what you don't have, you can't have anything else secure until you've got that. Well, so all right. Well, I think is there anything else that you want to share today? Otherwise, probably wrap up.
You can't ask me that because I'll just talk forever.
Well, I think things might go poof in like 2 minutes. So.
Is there anybody in chat who wants to ask anything specific? Either direct in the Twitch chat or or for those of you who have been chatting with me in a side channel. Yeah, just I mean, yeah, I guess my parting thing would be really to reinforce make iterative improvements. Like every minor security improvement you make is a win, and you should celebrate those things.
Right.
Don't get down on yourself for not being Fort Knox level CI/CD OPSEC pipeline madness. Like, and honestly, you'll get a lot of value before you even dream about picking up some kind of crap product that decides to just like take the security salt shaker out and sprinkle it into your work.
Yeah, being able to ship updates and like just even just like keeping your base dependencies up to date is going to be huge. And like the big fulcrum, the machine you need for that is a functioning and secure CI/CD pipeline.
Yeah. If you can't, driving down time from commit to prod is critical. Your ability to react in a safe and consistent way is huge.
Yeah.
Impossible to understate that, I would say.
Yeah. And that's the machine that you'll use to make incremental improvements to, of course, not just the security, but product itself. So, all right. Well, thank you for joining me today, Jeff. I really appreciate your input and check. So hope you have a great evening. And thank you everyone for joining and for your questions. Take care.